Good evening and welcome to the Starliner Mission Control in Houston, where teams are preparing for the autonomous undocking and departure of the uncrewed Boeing Starliner spacecraft from the International Space Station. Undocking today is currently planned for 5:04 p.m. Central, 6:04 p.m. Eastern. I'm Anna Schneider with NASA Communications, and joining me today in Starliner Mission Control is Lauren Brennicke from Boeing Communications. Across the hall in the International Space Station Flight Control Room, we also have NASA's Rob Navius.
In preparation for today's undocking activities, the teams here in Starliner Mission Control and the Flight Control Room, Flight Control team in the International Space Station Flight Control Room recently completed the go, no-go poll for Starliner's undocking. The teams all polled go to proceed with undocking. And the team here in Starliner Mission Control is being led by Flight Director Chloe Maring. Today's undocking will set Starliner on its path home for landing at White Sands Space Harbor in New Mexico, targeting approximately 11 p.m. Central, Friday, September 6th, midnight Eastern on Saturday.
NASA astronauts Butch Wilmore and Suni Williams flew to the International Space Station in June as part of NASA's Boeing crew flight test, lifting off atop a United Launch Alliance Atlas V rocket from Space Launch Complex 41 at the Cape Canaveral Space Force Station in Florida on June 5th. The Starliner spacecraft docked to the International Space Station on June 6th. During the June 6th rendezvous, NASA and Boeing identified helium leaks and experienced issues with the Spacecraft Reaction Control System, or RCS thrusters, as Starliner approached the station. Since then, engineering teams have completed a significant amount of work, including reviewing a collection of data, conducting flight and ground testing, hosting independent reviews with agency propulsion experts, and developing various return contingency plans. The uncertainty and lack of expert concurrence did not meet the agency's safety and performance requirements for human spaceflight, thus prompting the NASA decision to return Boeing's Starliner spacecraft to Earth without astronauts Butch Wilmore and Suni Williams aboard. The uncrewed return allows NASA and Boeing to continue gathering testing data on Starliner during its upcoming flight home, while also not accepting more risk than is necessary for its crew. Wilmore and Williams will continue their work formally as part of the Expedition 71 and 72 crew through February of 2025. They will then fly home aboard a Dragon spacecraft with two other crew members assigned to the agency's SpaceX Crew 9 mission, NASA astronaut Nick Hague and Roscosmos cosmonaut Alexander Gorbanov. As part of NASA's Commercial Crew Program, this is Boeing's second flight to the International Space Station and third Starliner flight test overall, following a second orbital flight test in May of 2022. Yesterday, the hatches were closed between Starliner and the International Space Station. There are three hatches that separate the inside of Starliner from the orbiting laboratory: the Starliner hatch and the APAS hatch and No. 2 forward hatch on the station side. Following hatch closure, teams worked through steps to depressurize the vestibule, which is the area between the station hatch and Starliner hatch that were exposed to the vacuum of space prior to docking. Shortly after the go, no-go poll earlier today, where the joint teams here in the Starliner Mission Control and the International Space Station Mission Control polled go for undocking, NASA astronaut Suni Williams called down to the flight control team on Space to Ground to share some words with the team before Starliner's departure later today. We'll go ahead and replay that exchange for you now.
Station Houston, Space to Ground 2 for Starliner undock status.
Go ahead, we're with you.
Hey, Sunny, both the Starliner and ISS flight control teams have pulled go for undock at this time. The expected undock time is 22:04.
Okay, copy, 22:04. Hey, we're just looking at the flight control roster and wow, it is the all-star team. You guys, it is the time to bring Calypso home. You have got this. We have your backs, and you've got this. Bring her back to Earth. Good luck.
Sunny and Butch, this is Chloe. Just on behalf of the entire MO team, I know the other flight control teams around the building, we thank you for your endless support over the years. We've enjoyed every training event and every meeting. We remember every setback and every revelation with you. The teams on the ground have worked countless hours over the last few weeks, months, and for a group of us, years, to bring Calypso back, and we're ready to do that today. We wish you the best of luck in your increment, and Sunny, I will make sure the right people have your coming home song ready to play on Space to Ground when it's time for you guys to come home. Good luck and thank you.
Wonderful comments, Flight. We appreciate that, and we agree. Many years of great enjoyment, simming together, playing together, and being involved with each other's lives, and it's been special. Bring it home.
Happy, thank you, and have a good evening.
We are now just over 13 minutes away from today's planned undocking. As we continue to approach that undocking, you can see the team here and the Starliner mission control team working in tandem with the ISS flight control room across the hallway.
Just before we came on the air here, the teams opened up the helium manifold to check Starliner's leak rate. Everything looks good. The teams say the rate remains steady, and we have plenty of margin for the rest of the flight. So let's talk a little bit about what is coming up. At around 5:02 p.m. Central, 6:02 Eastern, we are going to be listening for the authority to proceed for undocking. After the ATP, or authority to proceed, is issued for undocking, the hooks on the NASA docking system will begin to open. There are 12 hooks that seal the surfaces between the docking system and the ISS International Docking Adapter, or the IDA. Once all of those hooks are open, springs on Starliner's docking ring will push the spacecraft away from the space station. So again, we're expecting that undocking at 5:04 p.m. Central, 6:04 Eastern. And then just a few seconds later, at about 5 meters out, our first separation burn. Starliner's thrusters will complete 2 short firings to gradually increase the separation speed to help the spacecraft carefully move away from the orbiting laboratory. The command given to Starliner will be to back straight away to the 200-meter mark, but then a few seconds later, a second command will be given before it gets too far to change that path and head up higher than station. These 12 pre-planned burns will be performed with Starliner's forward-facing reaction control system, or RCS thrusters, which have been performing nominally during this flight.
Starliner will then begin a breakout burn, which will take the spacecraft forward and above the station. During this burn sequence, Starliner's thrusters will perform a series of 12 short firings. This entire sequence will take about 5 minutes to complete and will allow Starliner to quickly break out to outside of the approach ellipsoid, or AE. About 4 minutes into this burn sequence, Starliner will exit the keep-out sphere, or KOS. The keep-out sphere is an imaginary 200-meter sphere centered on the space station. Once outside the keep-out sphere, vehicles must provide a 4-orbit safe free drift trajectory.
Around 5:10 p.m. Central, that automated breakout sequence will be completed. And then just 15 minutes later, we will be out of the approach ellipsoid. The approach ellipsoid is in the same family as the keep-out sphere, but this time it is an imaginary 3-dimensional ellipsoid around the space station. Vehicles outside the approach ellipsoid have to be on what we call a 24-hour safe free drift trajectory, and that means the spacecraft would not cross over that imaginary line for at least 24 hours, even if it lost all maneuvering capabilities. Once outside the approach ellipsoid, joint operations between the Starliner Mission Control and International Space Station Flight Control Room will conclude, and Starliner will be on a path back to Earth.
A few minutes ago, teams completed a final weather briefing to analyze weather predictions for the landing site at White Sands Space Harbor in New Mexico, and the weather continues to look good to support a landing later today. As part of the departure preparations for Starliner, mission managers completed a series of operational and weather checks. Yesterday, 24 hours before undocking, NASA analyzed the weather predictions for the landing site, and there are several different weather criteria that must be met, including winds at the selected landing site must be approximately 13 miles per hour or 12 knots or less when uncrewed, and ground temperatures must be warmer than 15 degrees Fahrenheit, and the cloud ceiling must be at least 1,000 feet. 1 nautical mile of visibility is also required, and the area must be clear of precipitation, thunderstorms, and lightning within an approximately 22-mile radius. A final weather check will also take place before the spacecraft's deorbit burn, which is currently scheduled for 10:17 p.m. Central, 11:17 p.m. Eastern.
And following the weather briefing, the navigation and docking lights on Starliner were turned on. The LADARs were confirmed to operate, and the RAL cards were enabled for departure. The LADARs, or laser detection and ranging lasers, create a 3D picture of the International Space Station for Starliner's computers to help the spacecraft guide itself around the ISS when it's flying close to the station. The LADAR system was developed and tested in orbit aboard the Space Shuttle as they docked with ISS. The RAL cards, or Remote Analog Interface Unit, gathers data on the status and health of critical spacecraft systems during all phases of the mission. This allows the important systems information to be stored aboard the spacecraft so engineers can review it once the spacecraft lands.
We're now just over 6 minutes away from the planned undocking at 5:04 p.m. Central. As we continue to stand by for Starliner's departure from the International Space Station, I'll hand it over to NASA's Rob Navius for an update from the International Space Station Flight Control Room.
Thanks, Anna. Here in the Space Station Flight Control Room at the Johnson Space Center in Houston, the flight control team led by Flight Director Anthony Varia is in the final moments before the expected undocking of Starliner from the forward port of the Harmony module on the International Space Station. Once the undocking is complete and Starliner has exited the approach ellipsoid that you heard Lauren describe just a moment or two ago, the 9 crew members on board the station, led by Commander Oleg Kononenko, will begin their sleep period. They're going to be moving into an off-duty period on Saturday. The vacancy of the forward port of Harmony will open up that port for the beginning of 2 crew rotations over the next several weeks. Next Wednesday, NASA's Don Pettit and Roscosmos cosmonauts Alexei Ovchinin and Ivan Wagner will be launching from the Baikonur Cosmodrome in Kazakhstan on a 2-orbit rendezvous to reach the International Space Station. That will swell the station's population to 12 and begin an 11-day handover with NASA astronaut Tracy Dyson and Kononenko and Nikolai Chub, who will be departing the station on September 23rd. A day later, if everything goes as planned, NASA's Nick Hague and Roscosmos cosmonaut Alexander Gorbanov will be launching from the Cape Canaveral Space Force Station on the SpaceX Crew Dragon Freedom They will be a two-man crew to reach the International Space Station and provide the orbital Uber, if you will, for Butch Wilmore and Sonny Williams to come home on next February, with Wilmore and Williams completing what is expected to be about a 262-day mission. Meanwhile, the Crew 8 crew, Matt Dominic, Mike Barrett, Jeanette Epps, and Alexander Grebenkin, are in the final weeks of their mission on board the station. They are planning to depart after a 5-day handover with Haig and Gorbanoff. That handover will lead the way for a departure on or around October 1st. The Crew 8 crew will then be coming home to bring the station back to its complement of 7 crew members. So with that, we're about 3.5 minutes away from the planned undocking of Starliner. We'll be watching carefully. It will take about 21.5 minutes from undocking for Starliner to exit the approach ellipsoid that you heard Lauren describe a moment ago. That's that 2.5 mile long by 1.2 mile wide corridor, if you will, the neighborhood of the International Space Station. So we'll be following along as Starliner begins its journey home and a landing at midnight Eastern Time at the White Sands Space Harbor in New Mexico. With that, we'll turn it back to you, Anna, in the Starliner control room.
Station Houston, Space to Ground 2 for Starliner undock status.
Go ahead.
ISS and Starliner flight control teams remain go for an on-time undock at 22:04. Please perform 1.106 cruise CST 100 approach and departure monitoring steps 2.2 and 2.3. Verbally call Houston when physical step is confirmed. Be advised that NDS hook motors are driving. Space-to-space comm may be ready.
ISS crew copies ready for undock monitoring.
Thank you, Rob. And we just heard some conversation between the crew on the International Space Station and the teams here in the Starliner Mission Control, confirming that we are continuing to be go for an undock in just under 2 minutes from now at 5:04 p.m. Central, 6:04 p.m. Eastern. We are standing by for the command of the undock ATP or authority to proceed. Once the authority to proceed is issued for undocking, the NDS or NASA docking system hooks will begin to open, and there are 12 hooks that seal the surfaces between the NDS and the ISS International Docking Adapter, or IDA. Once all 12 hooks are open, springs on Starliner's docking ring will push the spacecraft away from the space station.
And Flight Director Chloe Marion just asked for quiet in the room as we are approaching 1 minute out from Starliner undocking.
And we just heard confirmation that the umbilicals are retracting and hooks are beginning to drive.
Thirty seconds. Separation confirmed. Starliner is now backing away from station and starting its return to Earth. Starliner thrusters will then complete 2 short firings to gradually increase the separation speed to help the spacecraft carefully move away from the orbiting lab.
The vehicle is now about 2 meters away from the International Space Station. At the time of undocking, Starliner and the International Space Station were flying approximately 260 statute miles over central China.
Starliner will be beginning a breakout burn soon, which will take the spacecraft forward and above station. During this burn sequence, Starliner's thrusters will perform a series of 12 short firings. The entire sequence takes about 5 minutes to complete and allows Starliner to quickly break out to outside the approach ellipsoid, or AE. And about 4 minutes into the burn sequence, Starliner will exit the keep out sphere, or the KOS. And you can see those thrusters firing there on the left of your screen as Starliner backs away from space station.
And we are now just at 35 meters away from the International Space Station. We saw a good first burn.
Houston, ISS thrusters enabled.
Confirmation, all 27 jets have fired.
Houston copies, ISS thrusters enabled.
And you're seeing the light show there on your screen.
And the first 3 of the 12 firings have completed, and there's about a 100-second pause until the 4th burn.
Starliner is about 60 meters away. And flight controllers are reporting good attitude and good control.
We are standing by for the 4th of the 12 burns in the series of firings as part of the breakout burn. As a reminder, the entire sequence will take about 5 minutes to complete. About 4 minutes into the sequence, Starliner will cross what is known as the keep-out sphere. The keep-out sphere is an imaginary 200-meter sphere centered on the space station. We are 15 seconds away from the 4th burn in the series of 12.
And you just saw burn 4, which just completed. We're hearing good burn.
And the 5th burn in that sequence of 12 just completed, and it was a good burn. The 6th burn in the series of 12 was just completed, and it was a good burn. We are halfway through the series of 12, 6 more to go.
You might be able to see some of those lights on the front of Starliner, a red and a green and a white. Those indicate the different sides of Starliner, and they're used by the ISS crew to watch Starliner move away from the ISS along the undocking axis.
And we just heard good confirmation of both burns 7 and 8 completed. Starliner undocked approximately 5 minutes ago and has just a handful of short firings left in its breakout burn, and it is now about 150 meters away from the International Space Station. And we heard confirmation of a good burn 9, 3 more to go.
Burn 10, good burn.
We have one more burn to go, but they have confirmed that Starliner has crossed the Keep Out Sphere, or the KOS, which is an imaginary 200-meter sphere centered on the International Space Station that helps flight controllers here on the ground monitor the arrival and departure of visiting vehicles.
Station Houston, Space to Ground 2, Starliner has exited the Keep Out Sphere.
Copy, she's exited the Keep Out Sphere.
A reminder, this automated breakout sequence was chosen to use Starliner's forward thrusters, which have remained nominal during this flight.
And we heard confirmation that all 12 burns in this series of breakout burn firings have completed, and they were all good burns. Starliner has crossed the Keep Out Sphere. So the next milestone for Starliner's departure will be crossing the approach ellipsoid, or AE. The AE is another invisible shape monitored by the flight control team, measuring 4 kilometers by 2 kilometers by 2 kilometers. Starliner is scheduled to cross the approach ellipsoid in about 10 minutes. Vehicles outside the AE have to be on what we call a 24-hour safe free drift trajectory, which means the spacecraft would not cross into the approach ellipsoid for at least 24 hours, even if it lost all maneuvering capabilities. Once outside the approach ellipsoid, joint operations between Starliner Mission Control and the International Space Station Flight Control Room will conclude, and Starliner will be on a path back to Earth.
We're now taking a look from the VESTA system, which stands for Vision-Based Electro-Optical Sensor Tracking Assembly. It's a bit of a mouthful, so we like to call it VESTA. And this is a look from Starliner back at the International Space Station. The system is really the eyes of Starliner. It's able to pick up on features on the outside of station, like handrails and reflectors. You can see some of that on your screen there in the outlines. And it's the way to assess Starliner's position and attitude. It also gives the ground teams a very accurate look at Starliner's location relative to the station. So earlier we were taking a look from the station back at Starliner. Now we're looking from Starliner back at station.
We're just under 10 minutes away from the AE exit, so in the meantime, we will check back in with NASA's Rob Navius in the International Space Station Flight Control Room. Rob?
Thank you, guys. Flight Dynamics has reported that Starliner is on a perfect trajectory backing away from the International Space Station and opening a rate of about 13.5 statute miles per rev. At the time of the deorbit burn, at 10:17 and 13 seconds p.m. Central Time later this evening, the vehicle will be about 56 statute miles away from the International Space Station. That deorbit burn, by the way, will be a 59-second burn to slow Starliner down by 129.9 meters per second, a 4 OMAX burn. OMAX, the acronym for the Orbital Maneuvering and Attitude Control System, thrusters and jets on the Starliner spacecraft that will enable Starliner to begin to drop out of orbit for its intended southwest to northeast trajectory across the Pacific Ocean, across Baja California, and heading towards its landing at the White Sands Space Harbor in New Mexico. With the forward port of Harmony now vacant, that sets the stage, as I mentioned a few minutes ago, for the start of a couple of crew rotations that are coming up. Down at the Baikonur Cosmodrome in Kazakhstan, Don Pettit of NASA and Roscosmos cosmonauts Alexei Ovchinin and Ivan Wagner and their backups are in the final stages of their preparations for launch next Wednesday. Their Soyuz 2.1A booster and the Soyuz MS-26 spacecraft that they will ride to orbit, that vehicle will roll out to the launch pad in Baikonur on Sunday, and then final preparations will lead them to a launch next Wednesday at 11:23 a.m. Central Time, heading for a two-orbit, 3-hour, 10-minute journey to dock to the International Space Station's Rassvet module. Now, that forward port on Harmony that was just vacated by Starliner's departure will be the port of call for NASA astronaut Nick Hague and Roscosmos cosmonaut Alexander Gorbanov, and their launch no earlier than September 24th on the SpaceX Dragon Freedom spacecraft off of Launch Complex 40 at the Cape Canaveral Space Force Station. That will be about a 30-hour transit for those two crew members to reach the International Space Station and the automated docking to the forward port of Harmony. Ultimately, Hague, Gorbanov, Butch Wilmore, and Sonny Williams will do a relocation of the SpaceX Dragon spacecraft from the forward port of Harmony to the zenith port of Harmony, opening up that forward port for the arrival of the next SpaceX cargo ship, SpaceX 31, that's scheduled for launch in October. So a lot of activities lying ahead for the space station crew. The crew aboard the International Space Station soon will begin its sleep period and an off-duty day on Saturday, while the activity shifts over to the White Flight Control Room down the hall, as they are in a shift handover right now. Flight Director Rick Henfling will be taking over shortly to supervise entry and landing operations, and the team over there will be monitoring the progress of Starliner as it moves to its deorbit position about 56 statute miles away from the International Space Station. With that, we'll turn it back to the White Ficker and Anna and Lauren.
Thank you, Rob. Starliner is now about 750 meters away from the International Space Station as it continues to make its way to the approach ellipsoid exit. Again, that approach ellipsoid exit is targeted for 5:25 and 30 seconds p.m. Central Time, 6:25 and 30 seconds p.m. Eastern Time, and everything continues to proceed as planned with Starliner's departure and return back to Earth.
And you're looking live at Starliner in free drift. Engineers are telling us that the breakout burns all went well. Thrusters are all looking good. Everything is nominal as we continue up and around space station and head back to Earth.
Again, Starliner undocked just a short while ago from the International Space Station at 5:04 p.m. Central, 6:04 p.m. Eastern, as the space station and Starliner were flying approximately 260 statute miles over central China. And shortly after that physical separation, Starliner's thrusters completed 2 short firings to gradually increase the separation speed and help the spacecraft carefully move away from the orbiting laboratory as part of the separation burns. And then Starliner began the breakout burn, which was a series of 12 short firings, which allowed the spacecraft to quickly move outside the keep-out sphere, and it is now approaching the approach ellipsoid exit. And once Starliner is outside of the approach ellipsoid, the joint operations between teams here and the Starliner Mission Control and the International Space Station Flight Control Room across the hall will end, and Starliner will be back on its path to Earth. And we are about 6 minutes away from that approach ellipsoid exit, and Starliner is now about 900 meters away from the International Space Station, traveling at a rate of 1.2 meters per second.
That dot in the center of your screen is Starliner, looking from space station.
We are now about 5 minutes away from the approach ellipsoid exit. Starliner undocked from the International Space Station about 16 minutes ago at 5:04 p.m. Central, 6:04 p.m. Eastern. Starliner is now just over 1,000 meters away from the International Space Station. After Starliner crosses the approach ellipsoid, the next milestones for the vehicle will be its entry cover closure, and that is planned for about 6:42 p.m. Central, 7:42 p.m. Eastern, and then there will be some checkouts of the OMAC thrusters at 7:05 p.m. Central, 8:05 p.m. Eastern. And then after that, we get into the entry and landing coverage, and the go-no-go for the deorbit burn will be at approximately 9:57 p.m. Central, 10:57 p.m. Eastern, following with the deorbit burn about 20 minutes later at 10:17 p.m. Central, 11:17 p.m. Eastern. Again, seeing good views of Starliner leaving the International Space Station. It's that distant dot on your screen. The vehicle is now about 1,120 meters away from the International Space Station. And we just heard confirmation that Starliner is out of the approach ellipsoid. The approach ellipsoid is a imaginary three-dimensional ellipsoid around the space station, and vehicles outside of the approach ellipsoid have to be on what we call a 24-hour safe free drift trajectory, which means the spacecraft would not cross into the approach ellipsoid for at least 24 hours, even if it lost all maneuvering capabilities. Now that Starliner is outside of the approach ellipsoid, joint operations between the Starliner Mission Control and International Space Station Flight Control Room will conclude, and Starliner is now on a path back to Earth. So once again, Starliner undocked from the International Space Station at 5:04 p.m. Central, 6:04 p.m. Eastern, as the space station was flying 260 statute miles over central China. Shortly after physical separation, Starliner's thrusters completed 2 short firings to gradually increase the separation speed to help the spacecraft carefully move away from the orbiting laboratory.
Starliner then began the breakout burn, and Starliner's smaller jets performed a series of 12 short burns to allow the spacecraft to quickly move outside the approach ellipsoid. Starliner again crossed the approach ellipsoid moments ago and is now on its journey home. The next milestones for Starliner ahead of its deorbit burn, targeted for 10:17 p.m., include crossing the entry cover, closing the entry cover, and conducting checkouts of the OMACs, or the orbital maneuvering and attitude control thrusters. Those are the bigger jets on Starliner.
For now, let's check in one final time with NASA's Rob Navius following Starliner's exit from the approach ellipsoid.
Thank you, guys. Here in the Space Station Flight Control Room, Flight Director Anthony Varia and his team will be remaining on console throughout the course of the evening, keeping a watchful eye on things.
Space to run 2 for Starliner status.
Go ahead.
Calypso has exited the approach ellipsoid. Sunny, we are ready for RWS teardown when you are.
Okay, she's on her way home. Congratulations to the Undock team, and we'll be tearing down the RW.
Copies, thanks.
Spacecraft communicators are here in the station flight control room talking to Sunny Williams, International Space Station. The Starliner is perfect trajectory, moving well away from the International Space Station for its deorbit burn at 10:17 and 13 seconds p.m. this evening. Once again, that'll be a 59-second burn of the 4 orbital maneuvering and attitude control system jets on the Starliner spacecraft to slow Starliner down by 129.9 meters per second, allowing it to drop out of orbit to begin its descent back into the Earth's atmosphere, and a landing just about midnight Eastern Time, 11 p.m. Central Time, give or take a few seconds, at the White Sands Space Harbor in New Mexico. With that, the space station team will begin to turn its attention to the next major activity. That will be the launch out of the Baikonur Cosmodrome in Kazakhstan on Wednesday of NASA's Don Pettit and Roscosmos cosmonauts Alexei Ovchinin and Ivan Wagner on the Soyuz MS-26 spacecraft that will increase the station's population from 9 to 12, and the beginning of a busy several weeks of crew rotations on the International Space Station, leading to the start of Expedition 72. So with that, we're going to call it a day here in the Space Station Flight Control Room. Turn it back to you guys in the white Flight Control Room down the hall.
All right, thank you very much, Rob. Starliner is now on its way back home to Earth and has about a 6-hour journey ahead of landing. We are targeting again around 11 o'clock Central, midnight Eastern for that landing at White Sands Space Harbor in New Mexico.
We will resume live coverage of Starliner's deorbit entry and landing beginning at 9:50 p.m. Central, 10:50 p.m. Eastern. Until then, thank you for joining us for Starliner's undocking and departure from the International Space Station. This is Mission Control Houston.
Good evening and welcome to NASA's Johnson Space Center and our coverage of Boeing's crew flight test. I'm Brandy Dean with NASA.
And I'm Lauren Brennicke with Boeing. Starliner safely departed the International Space Station and is on its way back to Earth.
Starliner is making its return autonomously tonight without NASA astronauts Butch Wilmore and Sunny Williams after a decision to return without crew was made during a flight test readiness review last week. But the team here in Mission Control will be watching over Starliner over the course of the next hour and a half as the spacecraft fires its engines to drop back into Earth's atmosphere and make its way down for a landing in New Mexico at about 11 p.m. Central or midnight Eastern.
The team here is led tonight by Flight Director Rick Henfling with weather assistance from Flight Director Mike Lammers. Henfling is just under 7 minutes away from polling the flight controllers here in the room on their readiness for Starliner to perform its deorbit burn at Starliner's landing zone. Teams in Florida, Houston, and New Mexico have been monitoring the spacecraft, famously undocked from the International Space Station at 5:04 p.m. time while flying 260 miles over central China.
NASA astronauts Butch Wilmore and Sunny Williams National Space Station in June as part of NASA's Boeing crew flight test lifted off a United Launch Alliance Atlas V rocket from Complex 31 at Cape Canaveral Space Force Station in Florida. That was 5th, they arrived at the International Space Station on June 6th. During that June 6th rendezvous, NASA and Boeing identified helium leaks and experienced issues with the Starliner's reaction control thrusters as the spacecraft approached the space station. Since then, engineering teams have completed a significant amount of work collecting and reviewing data, conducting flight and ground testing, hosting independent reviews with agency propulsion experts, and developing various return contingency plans. Uncertainty and lack of expert concurrence did not meet the agency's safety and performance requirements for human spaceflight, thus prompting NASA's decision to return Boeing Starliner spacecraft to Earth without the astronauts, Butch Wilmore and Sunny Williams, aboard. The uncrewed return allows NASA to continue gathering test data on Starliner during its upcoming flight home, while also not accepting additional risk for the crew. Wilmore and Williams, meanwhile, have formally joined the Expedition 71-72 crew and are going to remain at the space station conducting science experiments and helping with maintenance through February 2025. They're going to fly home aboard a Dragon spacecraft with 2 other crew members assigned to the agency's SpaceX Crew 9 mission. That is NASA astronauts Nick Hague and Roscosmos cosmonaut Alexander Gorbanov. On Thursday afternoon, the hatches were closed between Starliner and the International Space Station. And earlier today at 5:04 p.m. Central, the docking hooks released Starliner, allowing it to separate and begin moving away from the space station and into place for its journey home. You can see that video from earlier today playing here.
We saw a beautiful display of Starliner's thrusters there.
Butch Wilmore and Sunny Williams also had some words to say for the teams here on the ground as Starliner was making its way away from the space station.
Station Houston, space to ground 2 for Starliner undock status.
Go ahead, we're with you.
Hey, Sunny, both the Starliner and ISS flight control teams have pulled go for undock at this time. The expected undock time is 22:04.
Okay, copy, 22:04. Hey, we're just looking at the flight control roster and wow, it is the all-star team. You guys, it is the time to bring Calypso home. You have got this. We have your backs, and you've got this. Bring her back to Earth. Good luck.
Sunny and Butch, this is Chloe. Just on behalf of the entire MO team, I know the other flight control teams around the building, we thank you for your endless support over the years. We've enjoyed every training event and every meeting. We remember every setback and every revelation with you. The teams on the ground have worked countless hours over the last few weeks, months, and for a group of us, years to bring Calypso back, and we're ready to do that today. We wish you the best of luck in your increment, and Sunny, I will make sure the right people have your coming home song ready to play on Space to Ground when it's time for you guys to come home. Good luck, and thank you.
Wonderful comments, Flight. We appreciate that, and we agree. Many years of great enjoyment, simming together, playing together, and being involved with each other's lives, and it's been special. Bring it home.
Copy. Thank you, and have a good evening.
That again was a conversation recorded earlier today between astronauts Sonny Williams and Butch Wilmore talking with the Starliner flight director at the time of undocking, Chloe Meering. Since that undocking, when Starliner and the space station were flying 260 miles above central China, Starliner has been steadily increasing the distance between it and the space station, ensuring that it will be able to get into place to perform a 10:17 p.m. Central deorbit burn. Now in about 20 minutes. While it has been moving away, the flight controllers here on the ground took the opportunity to perform a few tests of Starliner's thrusters. During the test, the crew module's 12 small reaction control system thrusters, one of the jets, didn't fire when commanded. The reaction control system thrusters on the crew module are used to steer Starliner as it makes its way back down to Earth after the service module has been jettisoned. Because those 12 jets are divided into two redundant strings of 6, Starliner only uses one string during normal operations. So although this means a slight loss of redundancy, it shouldn't keep Starliner from getting through re-entry and landing as expected.
Yeah, and Starliner has plenty of redundancy with this part of the prop system on the capsule, so no impact to the deorbit burn or reentry, and it's not required for flight rules. The team also tested 10 of the 28 reaction control system jets in the service module after undocking, and they all performed as expected.
And here on the ground, the team just gave their go officially to Rick Henfling, today's flight director, meaning that tonight's landing of Starliner is on. That, again, is scheduled to happen, touchdown at 11 p.m. Central Time or midnight Eastern Time. Once again, flight director Rick Henfling has gotten a go from Starliner's for Starliner's deorbit burn from all of the flight controllers watching over the spacecraft's return tonight. And that again means we are officially on for Starliner's return to Earth at about 11 p.m. Central Time or midnight Eastern. The deorbit burn at 10:17 p.m. Central Time is now just 17 minutes away. That'll be a 59-second firing of 4 of Starliner's orbital maneuvering and attitude control thrusters on Starliner's service module. And joining us live from Starliner's landing zone with White Sands at White Sands Space Harbor in New Mexico, our colleagues Leah Cheshire from NASA Public Affairs and Boeing's Josh Barrett. Leah and Josh, how is it going out there?
Thanks, Brandy. It is going well out here. We are out here in White Sands. The weather right now is about 75 degrees and very light winds, approximately 6 miles per hour. This looks like potentially a picture from earlier today. It is quite dark out here at this point. We have a beautiful view of the stars, and we are lined up in the convoy getting ready to roll.
That's right, Leah. So I've been out here for both of Starliner's previous landings. The first one was very cold. The second one was quite warm, and this one feels just about right. We're following along with 2 command vehicles. We've got the MLCC, or the Mobile Landing Control Center. They're tied in down in Mission Control in Houston with the people that you're seeing on your screen right now. We also have the MDTV, that's the Mobile Data and Tracking Vehicle, and on top of that, it's got a suite of optics on top. There's an infrared camera and 2 visible cameras, one of them with a telescopic focus. So those will be the first things that we'll be seeing Starliner with here from the landing zone, and you should be seeing those on your screens as well. And Leah's got a few more things that she'll talk about that should get some cameras on Starliner as well.
Yeah, especially the WB-57, NASA's plane. That took off just a few hours ago, just as we were heading out here to the landing site. So we arrived here at about 6 p.m. local time, which is mountain time. And since then have been getting ready, lining up, doing communications checks between the various teams, and just getting ready to eventually drive out to the landing site once Starliner comes down. So it is a sea of white gypsum sand out here. And teams are continuing to just prepare as soon as we get into that deorbit burn. So they are actually in a huddle right now, talking through some of the next steps for tonight, getting ready to come and join us here in the convoy as we await to see the deorbit burn. So with that, right now, we are going to turn it back over to you, Brandy and Lauren. We are going to stick around, though, and cannot wait to see Starliner coming straight across the sky. Thank you.
Thanks so much, Leah and Josh. We are hoping to get some good views from where you guys are at later today.
Now, once we make that final burn to get out of orbit today, it'll take about 45 minutes for Starliner to reach its destination. Again, White Sands Space Harbor, New Mexico, where we just spoke with our colleagues from. Starliner is currently flying with its solar arrays pointed toward the sun, recharging the internal batteries to keep its systems powered through landing. The orbital maneuvering and attitude control thrusters, or what we call OMACs, will fire for about a minute to conduct the deorbit burn. That maneuver slows the spacecraft down from orbital velocities and allows it to start falling back to Earth in a head-down position. At the end of that deorbit burn, Starliner angles itself for re-entry.
The deorbit burn is just the first in a series of milestones we're going to be ticking off tonight. To give you the full rundown, deorbit burn is scheduled for 10:17 p.m. Central. As we said, we just got the go for that a few minutes ago. It's going to be followed by the separation of the crew module from the service module at 10:20 p.m. and the crew module will then continue on its own. At 10:45 p.m., Starliner will begin to feel the effects of the Earth's atmosphere again for the first time since its ascent in June. And a few minutes later, around 10:47, the heat from Starliner's reentry will become so intense that that plasma will begin to form around the spacecraft, causing a blackout in communications with Starliner for about 4.5 minutes. Once Starliner clears that blackout period, things will begin to happen very quickly.
Yeah, so then up next at 10:56, when Starliner is about 4.3 miles above Earth, the spacecraft will be done with the forward heat shield that is at the top of the capsule that helped protect it through re-entry, and it will jettison it to make way for the parachutes that are stored underneath. And then almost immediately, those parachutes will begin to deploy. First with two smaller drogue parachutes that are meant to take the edge off Starliner's speed. They open up in stages over the course of about 28 seconds. And then at 10:57 p.m., when Starliner is about 6 miles up, the drogue parachutes are released and 3 main parachutes are deployed. They also open in stages over about 16 seconds, but they stay with the spacecraft all the way until touchdown. And again, we are expecting that touchdown to come at 11 p.m. Central. Just before the touchdown, however, at 10:58 p.m., Starliner also sheds its base heat shield at the bottom of the capsule to make way for the inflation of 6 landing airbags hidden underneath it, and those will cushion the vehicle as it lands in New Mexico's desert.
It's probably worth mentioning that we do not have video from Starliner. If you think back to June on its ascent and journey to the International Space Station, it's not able to send video down when it's not connected to the space station, so we won't be getting in-flight views from it, but we do have several cameras out at the landing site as well as some aircraft in the area that we are hoping to get some views from. But of course, it is going to be pretty dark out in the desert at night, so they may be infrared or black and white views, but hopefully we'll get some good camera views to show you.
And we're taking a live look now from the landing site, but the shot is quite dark at the moment. You can see just a few lights blinking there. Hopefully, as we get closer to the ground, as Starliner gets closer down, we will have some better shots. The landing and recovery teams have been out in the desert preparing for the spacecraft's return for several days. I've been speaking with them to catch up on some of the preps that have been taking place. They ran through a full mission dress rehearsal where they practiced the landing and recovery operation with all the different groups and functions. And they've also been keeping a close eye on the wind direction to establish the best recovery zone out at White Sands. They've even sent up some weather balloons to check the wind speeds.
Tracking vehicles out there are equipped with cameras, so the team has been calibrating those. And again, although we don't expect any views from Starliner on its way down, we're hoping to get some good ones from those tracking cameras as well as aircraft in the area. We plan to have the WB-57 getting views while it is about 16,000 feet above the ground until the drogue parachutes deploy. And then at about 6,000 feet, we hope to see views from a Cessna in the area. And this is actually a current view of the Cessna as it makes its way out to the landing site, White Sands Space Harbor in New Mexico. And this is a shot from one of the ground cameras that we have on site. So again, although it is dark there, we are hoping to see some good views.
And in the last few hours, the teams there on the ground have been at the holding area loading up their vehicles, doing last-minute checks, making sure all the equipment is ready to go, and then shortly they'll begin moving into place to watch Starliner make its final approach. And then once Starliner lands, teams will move closer in a very strategic way. They will first stop at about the 500-foot mark away from the spacecraft, and then they'll move in closer to the 150-foot mark while ground teams safe the vehicle.
That first team on site with Starliner will be what we call the Gold Team. They start recovery operations by performing what's called a sniff test, where they use sensors to check for hydrazine, one of the propellants that Starliner uses. They'll be wearing protective gear known as hazmat suits to prevent exposure to hypergolic propellants. Hydrazine is used as propellant, and if it turns into a vapor, it can be toxic. After the sniff test, they will notify the rest of the convoy when it's safe to approach, and then they're going to check the winds, make sure the entire landing and recovery team is staged uprange from the direction the wind is blowing for added protection.
Now, everyone out there is part of a different color team, and they wear a vest with that color, so it's very obvious who does what. So the next step is the silver team, and their first job is to ground the spacecraft. Starliner will be powered down, but there could be some residual electricity. So before anyone can touch it, they will ground it and discharge it.
Teams here on the ground are reporting that everything is getting into good configuration for the deorbit burn. That's now just about 6.5 minutes away. Going on with what we were saying, we also will have the blue team that documents everything that's going on at the landing site. These are photographers from both Boeing and NASA who have situational awareness cameras. And again, here's a current view of those teams all ready to deploy at landing.
Yeah, that's the holding site that we were mentioning. And then, of course, you can see the mountains there in the background in this black and white view. Now, the green team hooks up the HVAC trailers to Starliner to get cooling on it, but their first job is to put up an environmental enclosure on the spacecraft, and that enclosure looks a lot like a big inflatable. It wraps around the vehicle to get cool air around it and make sure the critical systems don't overheat.
Then the red team opens the hatch. That is mostly Boeing Fire and Rescue. They will back up the mobile access platform to Starliner's hatch, giving the team access.
And Starliner will be bringing back more than 900 pounds of cargo, including a nitrogen oxygen recharge system, or what we call Norris tank, that NASA will service and refill for future space station needs. The teams will unload that cargo before Starliner heads back to Florida.
Just over 5 minutes to go now until tonight's 10:17 p.m. Central Time deorbit burn. Team here on the ground reports that Starliner has gotten into the right attitude, kind of the right way it's pointing for that burn. So everything is looking good. We're on track for landing at 11 p.m. Central, midnight Eastern. With just a couple minutes or 4 minutes left to go until the deorbit burn, we're going to check in once again with the landing team and Leah Cheshire and Josh Barrett.
Thanks, Brandy. Yeah, we are out here just waiting in the convoy area. Now, most of the team is taking part in a safety briefing right now as we prepare to watch the deorbit burn and the reentry and then move in toward the spacecraft. Like you mentioned, it's really dark out here. Josh and I were just able to take in the really beautiful sight of the Milky Way. It's so dark. So once the capsule starts to re-enter the Earth's atmosphere, we expect to have a pretty good view of the streak as that plasma builds up around the capsule itself.
That's right. We should be seeing it come just over the southwest horizon, right through the saddle of kind of the mountains that are just overlooking the mountain range here. And remembering back to OFT1, kind of the view that we should be having here is that we'll hear the sonic booms as well after we see kind of that plasma envelope. And then pretty quickly afterward, it is pretty remarkable how quickly it does end up over our heads. We'll see the flashes from the mortars, which deploy those forward heat shield parachutes, which take the forward heat shield off. Then we start hearing those mortars, and then the parachutes start to deploy. And then it's kind of slow motion from there as it drifts down.
And we're seeing a lot of movement as teams have just completed that safety briefing here. So they're now all walking to join us at the convoy. So it looks like we are just a few minutes away from the deorbit burn, and the show is really getting on the road soon. So with that, we're going to turn it back over to you in Houston.
We are just over 2 minutes away from the deorbit burn. At this point, Starliner has moved well away from the International Space Station and quite a few kilometers ahead of it as well. We had a number of smaller burns to ensure that Starliner was at a safe distance away from the space station before it performs the deorbit burn that will bring it out of orbit and on its journey back to Earth.
And Flight Director Rick Henfling and his team expect Starliner's orbital maneuvering attitude control thrusters, also called OMACs, to fire around 10:17 Central Time, pushing the spacecraft out of its orbital flight path and onto its journey home. This deorbit burn will set us up for a touchdown time of about 11 p.m. Central or 10 p.m. Mountain Daylight Time out there in White Sands, New Mexico.
Once it's there, control teams in Houston will begin powering off Starliner's radiators and solar arrays as the spacecraft now has enough power to get home, and sublimators will be taking over cooling. They use water to cool the cabin. Starliner is also, as we said, now in the correct attitude for performing the deorbit burn, and at this point, the service module and crew capsule are still attached to each other. 4 of the service module's 12 aft-facing orbital maneuvering and attitude control engines are going to be powering the deorbit burn, allowing them to separate safely.
And those engines are each 1,500-pound thrusters, meaning this burn will take about 6,000 pounds of thrust, slowing Starliner from its current orbital velocity and bringing it back to Earth's atmosphere for a smooth landing. The small reaction control system, or RCS thrusters, assist here in holding Starliner in the correct attitude. During this test flight, our teams ran roughly 1 million computer model simulations showing all the different thruster combinations possible for a safe return to Earth today.
Just 20 seconds now until the burn starts. It'll last 59 seconds. And again, you be firing those orbital maneuvering and attitude control thrusters. Four orbital maneuvering and attitude control thrusters on Starliner's service module are now firing, slowing Starliner down as the capsule begins its journey back to Earth. This will take about 59 seconds to complete. We're hearing all thrusters firing well so far. You can see here those representation of those thrusters firing. Starliner's maintaining its attitude, and as those large orbital maneuvering thrusters are firing, smaller reaction control system thrusters are also working, keeping the spacecraft in the correct position for the burn. Still looking good. And we did see the Doorbert burn cut off successfully. Teams here on the ground reporting a good burn. Starliner is now on its way to White Sands Space Harbor in New Mexico, and a planned touchdown at about 11 p.m. Central, midnight Eastern Time. Next up on the to-do list for tonight is the separation of the service module. With the service module's job done, it'll be disposed of over the Pacific Ocean, leaving the uncrewed crew module to carry on alone. In addition to all its other jobs, the service module has spent the flight protecting the crew module's heat shield. Jettisoning it uncovers that critical piece of equipment, allowing it to shelter the spacecraft as it begins traveling back through the Earth's atmosphere.
The crew module will then make its final attitude adjustments to make sure the heat shield is at exactly the right angle to provide that protection. And those fine-tuned adjustments are really just a strong capability of Starliner's guidance, navigation, and control system. In fact, on the 2 previous flights, Starliner made bullseye landings thanks to that system.
Starliner's maneuvering into position for that jettison at this time. Team here on the ground reporting that Starliner is in a good attitude, pointing the right direction for the service module separation.
And the service module has just jettisoned, separated, and is now falling away. It will burn up during reentry over a remote part of the Pacific Ocean. And Starliner will continue on its path to New Mexico, where the landing and recovery team is waiting for touchdown. Starliner is now angling itself and its heat shield for reentry. The entry interface is coming up in just about 10 minutes. That's the hottest part of the reentry process, with Starliner's heat shield reaching about 3,000 degrees. To protect Starliner from those heat loads, the spacecraft has what's called an ablative heat shield. The outer surface of that shield heats up to a gas, which then carries the heat away from the crew module through convection. And our team calls this process a game of threes because during entry interface, the heat shield will handle those temperatures of about 3,000 degrees, but it will convert that heat to about 300 degrees with only 3 inches of ablator. And because of this protection during this hottest part of reentry, the inside of the spacecraft remains at about room temperature. When Starliner returned from its last 2 flights, the capsules landed with 2 black stripes up the sides, indicating the heat shield was ablated as intended. So we do expect to see that again today, and the team considers that a bit of a badge of honor.
Once again, we did see Starliner deorbit or performance deorbit burn on time at 10:17 p.m. Central Time, and then quickly turned around and jettisoned its service module now that it has performed its duty over the course of the mission. We are still about 20 minutes away from entry interface, but things will start to happen quickly after that. About 4 minutes after we go into the entry interface, the heat from Starliner's re-entry will become so intense that the plasma will begin to form around the spacecraft, causing a blackout in communications with Starliner for about 4.5 minutes. And after that, we'll see Starliner jettison its forward heat shield that's been protecting the parachutes during re-entry. Then, when Starliner is around 30,000 feet above the ground, the spacecraft's parachute sequence will begin. Two drogue parachutes will start slowing Starliner down, and then they'll detach, and 3 main parachutes will deploy and inflate. At about 3,000 feet off the ground, the base heat shield jettisons, exposing the airbags, and then at touchdown, those airbags absorb the initial force of landing, cushioning the spacecraft for a soft, safe return to Earth. Currently, Starliner is about 213 miles above the South Pacific Ocean. It's just past the southernmost portion of this final orbit, coming around the southern coast of Australia, and now is going to begin making its way northward towards the west coast of the United States for that landing at 11 p.m. Central Time, midnight Eastern Time at White Sands Space Harbor in New Mexico. Again, we've had the deorbit burn that took place just as planned at 10:17, a 59-second burn that changed the Starliner speed by about 290 miles per hour, 130 meters per second. That made way for the service module separation, and the next milestone we'll be watching for is the entry interface coming up around 10:45. Still about 10 minutes away. Live view here of the recovery forces staged near the landing site, ready to move in once Starliner touches down. We are taking off milestones as expected for that 11 p.m. Central, midnight Eastern, or 10 p.m. Mountain Time touchdown today in New Mexico.
Again, Starliner performed its deorbit burn about 12 minutes ago. The thrusters performed nominally, and the flight home is going smooth.
We're still about 14 minutes away from the entry interface, which is our next milestone. I think I said earlier that we were 10 minutes away. That was a mistake. But about 14 minutes from now, we'll be experiencing the atmosphere for the first time since Starliner launched. And since we do have a little time, we're going to check back in with the landing team. Leah and Josh, how are things going out there?
Thanks, Brandy. Yeah, that was a great view of the landing convoy all lined up. I was just watching some of the Gold team members getting suited up. As you mentioned earlier, that's going to be the first team to come in and inspect the vehicle. They're sniffing for those hypergalls or any of those dangerous fumes before the rest of the teams get the go to move in and approach the capsule. Of course, it's kind of a waiting game right now as we are still waiting to spot Starliner coming from the southwest. So a lot of us are outside of the convoy right now and keeping our eyes on the skies.
Yeah, that's right. We've got about just under probably 3 dozen vehicles all lined up in 3 rows, just waiting to get that touchdown signal. Again, going through that convoy list that you guys went through already so well, behind that Gold team, after Starliner is declared safe, the Silver team moves in and they do the electrical grounding. They'll also stabilize the vehicle just in case the airbags start deflating. We make sure that the hatch has a good stable orientation for Red team to come in, and they're the ones with the hatch orientation. And once the Red team establishes hatch access, actually the Silver team has a fun job tonight in the dark. They're going to go start looking for the pieces that came off of Starliner, those heat shields, some of those lids from those parachute mortars. And then after that, after Red team has hatch access and opens up the hatch, NASA's ISS program folks are going to come in for the cargo inspection.
So again, we are expecting to start seeing Starliner coming across the horizon around the time that entry interface begins. But until then, just wanted to give you guys a hit from the landing site and the latest that we have going on here. So we'll toss it back over to you in Mission Control Houston.
Thanks so much, Leah and Josh. We are watching for that entry interface as well. We're now about 12 minutes away. Starliner continuing to make good progress following in that 10:17 p.m. Central Time deorbit burn.
Again, we're looking at the landing and recovery team set up at the holding zone there at White Sands. Josh and Leah are embedded with that convoy, and they will make a very strategic move toward the spacecraft after touchdown, first stopping at about the 500-foot mark, and then they'll get the go to move forward to the 150-foot mark, and then once the vehicle is considered safe, they will move in.
With the deorbit burn complete and the service module separated, the spacecraft's heat shield is now exposed and ready to begin experiencing the atmosphere again. The Starliner is going to make some final attitude adjustments that keep that heat shield pointing at exactly the right angle.
And next up after that is entry interface, again, just coming up in a few minutes. At 400,000 feet above Earth, Starliner faces temperatures of 3,000 degrees Fahrenheit from the plasma created by air friction around the spacecraft. But Starliner can handle that heat with its heat shield, which is made of an ablative material designed to keep the inside of the spacecraft at about 70 degrees.
A few minutes later, Starliner will experience an expected blackout in communications, and that will last for about 4.5 minutes. At 30,000 feet and just 11 minutes before landing, Starliner jettisons its forward heat shield, exposing the spacecraft's parachute system. Then 2 drogue chutes will deploy, increasing drag and significantly slowing down Starliner. Then 3 pilot parachutes will pull out the main chutes, allowing the spacecraft to continue its slow and steady descent for another 8,000 feet towards the landing zone.
And once the main parachutes are fully inflated, Starliner's bucket handle releases. And what that does is it just basically levels out the spacecraft ahead of touchdown. And then the base heat shield that protected Starliner through reentry will separate at about 3,000 feet, uncovering the landing airbags. Those airbags, of course, will fill with nitrogen, allowing for Starliner to land softly and safely there in the sand.
Less than 10 minutes to go now before we do get to that entry interface point, and now just 24 and a half minutes away from the landing at White Sands Space Harbor. Everything's pretty quiet in the room, which is a good sign. Things are continuing to go smoothly as Starliner begins making its way back to Earth.
You're taking a look there at Flight Directors Rick Henfling on the left, speaking with Mike Lammers on the right. Rick is the flight director for this landing operation. Mike is weather flight director. They are tag teaming this operation.
Team has been keeping a close eye on weather at the landing site, but everything looks pretty good for tonight's touchdown.
Yeah, about 79 degrees Fahrenheit out there. They reported 10 miles of visibility. The winds are within the limits, so we are looking good for a touchdown. Coming up right about 11 o'clock p.m. Central Time.
Seven minutes to go now until entry interface, and then that intense heating will start about 2 minutes after we do begin the interface. That'll last about 4.5 minutes, during which time we'll be in a blackout. Starliner is currently about 130 miles, 149 miles rather, above the Pacific Ocean, heading northward towards the western coast of the United States, and it's touchdown in New Mexico.
We're taking a look here at the landing trajectory. There on the left of your screen, you can see that line that crosses over the Baja Peninsula, and that is the track Starliner will take as it makes its way into New Mexico. As it gets closer to the ground, people living in the area might get a bright shot of Starliner coming back through the atmosphere and landing there in White Sands, New Mexico.
You can also see there in the center of the screen the to-do list, basically, before we do get to landing. The service module separations highlighted in green because that one's already taken place. And next up is the entry interface, about 5 minutes away from now.
And flight controllers here in the room are reporting good attitude for that entry interface, coming up again in just under 5 minutes.
2.5 minutes left before Starliner begins to feel the effects of the Earth's atmosphere again. Everything continuing to go smoothly. Flight controllers here in the room are quiet as they're working through their steps, but all going well so far. Starliner is in position to begin experiencing that heat from re-entry. Now less than 100 miles above the Earth and heading towards the Baja Peninsula. We'll be flying over that before landing in New Mexico. Just 17 minutes to go until landing. Less than a minute now until we begin entry interface. Again, about 2 minutes after entry interface starts, we'll begin seeing the heating really get intense, and we'll go into a 4.5 minute blackout. Team here in the ground reporting entry interface has begun. They're seeing good range. Seeing another view from the landing site, or the teams getting ready to move out to the landing site here. A little better idea from this view of exactly how dark it is out there with all the lights of the vehicle shining. A minute and a half until we move into the blackout period for Starliner. And 14.5 minutes until we land in White Sands, New Mexico.
The Starliner enters Earth's atmosphere at 17 times the speed of sound, which could create a sonic boom for folks living in the area. It will then be slowed down by parachutes to a speed very similar to what you might experience while going down an elevator inside a high-rise building. The vehicle then comes to a safe, comfortable stop at landing.
.30 seconds now until the blackout period begin. Due to the compression of friction and friction of the air, the molecules generate a very hot plasma that causes the red-orange glow you often see appear in post-flight imagery on many spacecraft. Although we won't get to see that tonight, it will happen. It causes an expected communication dropout. This one will last 4.5 minutes as the vehicle goes through a time when plasma interferes with a satellite signal. We expect that blackout to end around 10:52 p.m. Central.
Well, this is also the time that I mentioned earlier where a Starliner in the past 2 flights has gotten that black mark along the sides of it, and that just really proves to our team that the ablative heat shield or the ablative material around Starliner is doing its job, and the heat shield is pushing that plasma away.
It's blackout time again. Lasts about 4.5 minutes. We've got about 3.5 left of it. After that, the milestones we'll be watching for include forward heat shield jettison at 10:56, when Starliner is about 4.3 miles above the Earth. Very soon after that, almost immediately, drogue chutes deploy. Those give a little bit of an initial slowdown to the vehicle before the really large main parachutes deploy. That happens when the Starliner is about 2.5 miles above the Earth. This is a live view from the International Space Station, where we're able to get a view of Starliner's track as it comes in. We are now less than 10 minutes away from landing at the White Sands Space Harbor, scheduled for 11 p.m. Central. We're also getting reports that the WB-57 is also able to see Starliner now as it begins coming in for its landing. We've still got just about a minute left to go before Starliner comes out of its blackout period. And this is a view from the WB-57, one of NASA's aircraft that is at the landing site, has been staged and ready to pick a Starliner, or pick up the view of Starliner as it comes in, and that is what we are seeing now.
And they're filming this video from about 16,000 feet.
The WB-57 should continue to give us a view until the drogue parachutes deploy, and then we hope to pick it up with the Cessna that is also in the area.
And flight controllers here in the room are reporting that we are out of that blackout period and everything is looking good. Starliner remaining nominal as she returns to Earth.
Again, this is a view from the WB-57.
Starliner showing a beautiful streak across the sky as she returns to White Sands, New Mexico. We're about 3 minutes away from the forward heat shield jettisoning. That's the next milestone we're looking for.
Starliner is currently about 27 miles above the Earth, and the team at White Sands reporting that they have seen it. We got a tally hole from them reported remotely.
That means they are seeing Starliner from the ground there in New Mexico.
This view is coming from the Cessna that's also in the area, picking up Starliner now from its lower altitude, about 6,000 feet above, whereas the WB-57 is about 16,000 feet up. We are now just 6 minutes and 22 seconds away from landing. We should also just be a couple minutes away from the forward heat shield jettison, which will bring on the drogue parachute deploy, followed by the main parachutes.
And the strobe lights on Starliner are now on. Starliner is now over the landing site, and that strobe light will help the teams actually track Starliner on the ground because it is very dark out there.
Now about 12 miles above the landing site and just 5 minutes away from landing. Watching now for the forward heat shield jettison. That should be coming up, again making way for the parachute deployment.
All right, and that action you're seeing on your screen, forward heat shield and drogues out.
Really interesting view of this coming down from the WB-57. See those two drogue parachutes now deployed. They slow the vehicle down initially until it gets to a safe speed for the enormous main parachutes to follow. About 4 minutes to go until touchdown. Now back to a view from the Cessna aircraft in the vicinity of the landing site. Again, this is a view from a little lower than the WB-57 we were seeing.
The next thing we're going to see here is the 3 main parachutes come out, and everything will happen pretty quickly from that point on.
After those mains are out, we'll see the bottom heat shield that has been protecting Starliner through its journey through the atmosphere come off. That makes way for the landing airbags to deploy.
And there's the main parachutes there on your screen. We see 3 out. currently reefing.
And the teams at the landing recovery teams report that they heard the booms as those came out.
3 good mains fully open there. You can see Starliner in a slight tilt, so we're going to see the rotation handle move here shortly, and it will level out Starliner. But 3 good parachutes, looking great.
Just a little over 2 minutes until the expected landing time, and we heard the rotational handle has been released, so you can see that tilt evened out. Next up is the back heat shield jettison. And there it goes. That again makes way for the airbag inflation.
Nice to see that. You can see the airbags deploying there on your screen. Those airbags are filled with nitrogen as they guide Starliner safely back to the desert floor. Just a beautiful sight as Starliner makes its way to the sands of New Mexico. And flight controllers confirming 6 good airbags.
This view still coming to us from the Cessna. We've got just about a minute left to go until the expected touchdown. I'll be watching for that time for you.
Just about 15 seconds away from expected touchdown. You're seeing the ground there in your screen as we get closer. Touchdown. Starliner is back on Earth. That landing coming at 11:01 and 35 seconds Central Time, 10:01 and 31 seconds Mountain Time at White Sands Space Harbor at the U.S. Army's Missile Range in New Mexico. Our landing and recovery teams will now wait for clearance before making their way to the spacecraft.
One of the changes required with no crew on board is that the team here in the flight control room will be the ones to command the parachute to be cut away so that the wind doesn't pull the capsule along. But that's no problem for them. So now with Starliner down, they can begin working on some of the post-landing to-do items. Again, we saw Starliner touchdown at 11:01 p.m. Central Time. That's 1 minute after midnight Eastern Time, or 10:01 p.m. Central at the landing site in New Mexico. This is a view from the Cessna, still watching the drones slowly make their own way down. Those, of course, are the drogue parachutes that preceded the main parachutes, first slowing Starliner down before the large parachutes opened.
And really just a flawless and beautiful descent of Starliner today. Even heard some cheers and clapping in the background.
This again is the drogue parachutes still making their way to the ground after Starliner has touched down with its main parachutes. Touchdown came at 11:01 p.m. Central Time. The team here in Mission Control will be working through some post-landing steps now. View here of Starliner at its landing site in White Sands at Space Harbor. The landing and recovery teams will soon begin making its way out to them to begin recovering the spacecraft. The team here in Mission Control is polling right now to see if everybody is ready to power off the vehicle. That again is a step that the flight control team has taken over with the lack of crew on board.
Once the spacecraft is powered down, they will be transitioning control of the spacecraft over to the landing and recovery team. And it's a little difficult to see in this shot, but there is a strobe light on Starliner that will help the teams follow it out there.
And the recovery team is on the move, but I think Leah Cheshire and Josh Barrett, our colleagues out there, may be able to give us one last update. Leah and Josh, can you hear us?
Great landing of Calypso. I don't think there could be a
Brady,
better
hopefully.
birthday.
Obviously, we did have really a great show. We were able to see the cameras that you were watching too from the WB-57, from the Cessna, from the International Space Station. But
Leah, can I interrupt you?
Yes.
Concur. It's been a really amazing day.
We were hearing a bit from Space to Ground there, but I think they've concluded, unfortunately. We'll see if we can get a recording of that for folks listening at home. But Leah, go ahead with your update.
Yeah, sorry about that. Couldn't hear that one here. But here
Sunny,
from the
MCCH here. Rick just wanted to offer that he's got one more hour here.
Hey, it's his birthday here.
Yeah, and that's what counts. Yeah, it was a good landing. It's pretty awesome.
You guys are the best. You are the best.
Thank you.
Sunny Williams there, offering a slightly early happy birthday to Flight Director Rick Hempling. He will be celebrating his birthday on September 7th, but technically in Houston, we're still a little less than an hour away from that. They are, of course, already on September 7th at the International Space Station. But Leah, if you were still with us, we'll still take that update if you can give it to us.
Yeah, so as I was saying, we got to see the capsule and the plasma trail coming up over the mountains from the southwest and we were all still standing outside the convoy to watch that happen. But the most unexpected part was when I could hear the main parachutes being deployed. It was very faint, just a little bit of a rumble, but that strobe light really helped us identify Starliner as it was descending, and it would reflect a little bit up onto those parachutes. So we actually had a decent view as it was coming down under those chutes. And now we are actually on the drive out, and we can see the strobe light. It's giving us a great direction as we head toward the capsule.
Yeah, that's right. We are actually making our way down the former space shuttle runway, literally driving right down the middle of it. Starliner is a little bit towards the southern end, so we see that strobe kind of in the distance there. But we will make our way to the 500-foot mark, where Goal Team will move in and begin their assessments. And then once they declare that proximity operations can begin, the recovery ops will really get underway.
And with that, I think we were going to toss it back to you, Brandy and Lauren. If you don't hear it from us again tonight, just wanted to say thanks for letting us be part of the broadcast and give you the perspective of all the hardworking ground teams, both NASA and Boeing, out here at White Sands in New Mexico. So with that, sending it back over to Mission Control Houston.
Thanks so much, Josh and Leah. It's great to see Starliner home, and I envy you the up-close view, but we appreciate your updates.
I do too. Starliner has returned safely. Well done to the entire team for completing the mission with a successful undocking, deorbit, and landing. Starliner has once again proven herself a safe ride to and from space. On behalf of the entire Boeing team, welcome home, Calypso.
And with that, we will also wrap up our coverage tonight. We would like for you to stay tuned for our 12:30 a.m. post-landing news conference. That is 12:30 a.m. Central Time, so about an hour and a half, a little less than an hour and a half from now, when we'll be giving you final thoughts on the activities of the night. But Starliner is home. Again, the landing came at 11:01 p.m. Central Time. And with that, we will sign off. Thank you so much for following along with us. This is Mission Control Houston. Good evening and welcome back to NASA's Johnson Space Center and our post-landing news conference for the Starliner crew flight test. Starliner touched back down on Earth today or yesterday, depending on where you're watching from, at 11:01 p.m. Central Time or 1 minute after midnight Eastern Time. Here today to discuss the mission with you and wrap it up, we've got Joel Montalbano, Deputy Associate Administrator for Space Operations, Mission Directorate at NASA headquarters in Washington. Steve Stitch, the manager for the Commercial Crew Program from NASA Kennedy Space Center in Florida, and Dana Weigel, the manager for the International Space Station Program here at NASA Johnson. I'll let them each make some opening remarks, and then we'll open up the floor for a question. If you do have a question, you can on the phone bridge, you can press *1 to let us know. Let's start with Joel.
Well, first of all, thank you for joining us, for those here in the room and for those online. As was said, NASA and Boeing safely returned the Starliner spacecraft just after 11 p.m. Central Time to the White Sands Space Harbor in New Mexico after spending approximately 3 months attached to the International Space Station. It's great to have the Starliner home. A safe and successful landing was exactly what we wanted. It was uncrewed. Everybody see the systems work is exactly what we wanted. It's important to remember this was a test mission, right? This mission. The team spent a lot of time understanding the board, doing additional testing out at White Sands, doing analysis here. And I mean the team, the NASA team, the Boeing team, across the partnership. We work together to get this data and pull things. We did learn a lot. This was a bit of a crew, the Starliner on the Atlas V, and the procedures and the processes for that. On approach, some manual piloting. We had a successful docking, and we had 3 vehicle on board the International Space Station as we learned to operate with the systems and the crew and the interfaces there. I want to go ahead and thank the Boeing team, the Commercial Crew Program, International Space Station Program, our international partners, and all the engineers that worked on this mission to get us where we are today. With that, I'll hand it over to Steve. Thank you.
Yeah, thanks, Joel, and thanks for your interest in the Commercial Crew Program, and thanks for being here at a relatively late hour. It was a great day today to return Starliner. It was great to have a successful undock, the orbit and landing of the vehicle. We're really excited to have Calypso back on the ground. You know, Sonny told the ground team, "You've got this, bring Calypso back," and that's what they did tonight. I am thrilled for our Boeing team and all of our colleagues that worked this mission across the country, on the NASA team and the Boeing team. They've put a lot of heart and soul into this mission over many years, and it's a testament to those people that we got the vehicle back safely today. I can tell you that CFT is very personal to our team and to a lot of the people that worked on the mission, and it represents a tremendous honor to bring the vehicle back, to achieve a lot of test objectives today when we brought the vehicle back, and then really pave the way for future Starliner missions. I'm happy to report Starliner did really well today in the undock, the orbit, and landing sequence. You know, we used the NASA docking system for the second time on the mission to undock from the space station. That system performed really well. It's a derivative system what we use for Orion down the road, so it was good to pave the way for Orion as well. The spacecraft executed a nominal breakout sequence, the first time we've used that to back away from the station. We backed out to about 5 meters and then did a series of about 12 burns using the service module forward jets. And then we opened, after that sequence of maneuvers, we ended up opening at about 22 kilometers per rev away from the space station. All those thrusters did really well through that Sept sequence, no problems at all, no fail-offs or any problems at all. You know, we had a good chance to look at the helium system today when we, before we undocked, we repressurized that system. We had a criteria of 8 psi per hour in the ullage system for that, the helium, and we were about 4.5 psi per hour, so the helium system performed really well. And then, you know, when we backed away from the system, or from the space station, we did hot fire a number of thrusters on the service module. All 8 of those forward thrusters worked just great. We were able to look at the thrust of those thrusters, and it was nominal. All were performed at 100%, and we also hot fired 2 aft thrusters, and those worked well. We had great performance from the GNC system, the guidance navigation control, the Vesta system. Last flight on OFT2, we had a little bit of trouble with what we call a calibration maneuver to really make sure that the attitude is good for this space integrated GPS INS system, and that went really well. We had a deorbit burn that executed on time at 11:17 p.m. Central. It was about 130 meters per second, 58-second burn. It was a really good burn, and the service module thrusters performed well for that burn. The OMAX performed well. You know, we watched the burn. We saw a couple things in the starboard doghouse. You know, we talked a little bit about the temperatures there being a little higher. One of the thrusters, S2A2, didn't fail off, but it had a little higher temperature than expected, so we'll look at that data a little bit after the flight. And then another thruster in the top doghouse had a little higher temperature. We intentionally had planned to inhibit the software to let thrusters fail off during the deorbit burn, and that worked fine. So we really need to go back and look at all that data. The service module separated away just fine. That sequence went well. Once we separate the service module, we don't have good insight into those thrusters on the service module, but we expected it to be in the Pacific Ocean, right where we intended it to be. During entry, the vehicle performed great. It flew just fine. The GNC system performed well. Perfect entry. The one thing that we will have to go look at after the flight is when we hot fired before we had the entry, we hot fired on the crew module. There's 12 thrusters, and one of the upfiring thrusters did not perform at all. We hot fired it twice, and we used 2 different methods to talk to it, 2 different parts of the avionics system, and we never saw any chamber pressure or any pulses there. It looked like this is different than the service module thrusters. It's what we call a monopropellant system. It's very simple. It has a valve that opens, and then the propellant flows across a cat bed, and as it flows across that cat bed, there's a reaction and causes thrust. And for some reason, that thruster did not perform, but we used the redundant thruster on the other manifold. There's another upfiring thruster that worked just fine during entry, but something we'll have to go work at. It was a bullseye landing, great landing out at White Sands. The one thing we worked a little bit during entry is, for some reason, when we came out of the plasma, the navigation system, we call it the SIGI 3, kind of failed off temporarily, and then that system was brought back on, and it was tracking just fine. SIGI 2 also had a couple little hiccups during entry. We'll have to go look at that. That's really the only things that happened during entry. The sublimator that we had a little trouble with, that's a cooling device that is used to cool the vehicle during entry. It performed really well. We had a little trouble forming what we call an ice block on that during ascent, and that performed great tonight. It's really great to get the spacecraft back, and then we'll start the next steps. So we've been talking to the Boeing team already about next steps. We want to get into the spacecraft and start working on the helium system. We talked about, we know we have a seal that we've got to go replace on the flanges on the RCS thrusters. We need to upgrade that material to make it hypergol compatible, and then maybe a little bigger size. We'll do that. Boeing's already formed teams to look at the changes that need to be made for Starliner 1 in terms of the thermal environment in the doghouses. Can we do something different to make the doghouses a little less thermally severe for the OMAC burns and the thrusters? A second team is looking at the hot fire of the thrusters that's needed on the service module to complete the qualification and make sure we understand which pulses cause the Teflon seat on the oxide to swell. And then thirdly, there's a GNC team already formed to look and figure out how we go fly the vehicle differently. Can we change the dead bands? Can we change the way it flies to not stress the thrusters? And so that work has already started. And that's really the path to Starliner 1. So I'm super proud of the team. It was a great day for the Commercial Crew Program and also for Boeing. Congratulations to that team who worked so hard. It's great to have the spacecraft back, and we're now focused on Starliner 1, and I'll turn it over to Dana.
Thank you very much, Steve. And thank you all for being here with us at this very late hour and for your interest in the undocking of the Starliner from the International Space Station and its successful landing. I want to congratulate the Boeing team. They did a fantastic job with the operations this evening. They had to make a number of changes to the plan in short order. There were a lot of differences between the crewed and the uncrewed mission, including, as Steve talked about, the differences in the departure sequence. Fantastic job executing that. After Starliner undocked from the Harmony or Node 2 forward port, it backed away and then executed a series of breakout burns. It went up, over, and behind ISS. The crew was watching it until it was out of view, but then they came back and they watched the re-entry and the deorbit. In fact, they got some really neat views of the Starliner streaking through the atmosphere using some of the station video cameras on board. Pretty neat to see. The rest of the month in front of us on board station is really busy. I know I've talked to you about this before, but just as a reminder, next week we've got the Soyuz crew exchange with the launch of the 73 Soyuz on September 11th, bringing up NASA astronaut Don Pettit. And then we're returning NASA astronaut Tracy Dyson on the 72S Soyuz when that comes home. At the end of the month, we'll bring up Crew 9, do a handover between Crew 8, Crew 9, and then bring the Crew 8 vehicle home. I do want to express my sincerest appreciation for the team. They worked tirelessly over the whole summer. You know, we had the Starliner on board station for months. Most folks were working nights, weekends. They did an excellent job. The proof is in getting the vehicle safely home today. I know we've got a lot of things that we learned on the mission. We've got work in front of us, but I know that we've got the right teams in place to tackle these challenges and help us fly our future Starliner missions. And with that, I will hand it back over to Brandy.
All right, thank you. Okay, so we're going to start with questions here in the room, then we'll take them from the phone bridge. A reminder, if you're joining us by phone, let us know you have a question by pressing *1. And if your question gets answered and you want to withdraw it, you can press *2 to get out of the queue. But let's start here in the room. How about Eric?
Hi, Eric Berg with Ars Technica. Thanks for the great show tonight. It was really a stunning reentry. I wanted to ask about the arc of the Commercial Crew Program. I was going to ask both Boeing and NASA, but I guess they didn't show up for some reason. But anyway, it's been a decade since the CCT CAP awards were given out. I had to go look up that acronym. I'd forgotten it. It was a big experiment in fixed price contracts in human spaceflight. And so I'm just wondering, a decade later, and literally it's been a decade, after all that's happened with Dragon, with Boeing, with the delays, and now with this mission, just to get a sense of you from NASA, is the experiment a success, and kind of what is the future of human spaceflight with this commercial approach?
I'll start, from a commercial standpoint. We have 2 crew vehicles, the Dragon, Starliner, and obviously some work that we need to do on Starliner. We have commercial vehicles with cargo vehicles in the Dragon and the Northrop Grumman Cygnus. We have the Dream Chaser that's coming up next year. And so is it slower than, what we expected? Absolutely, right? It is slower, but we're making progress. And to me, we are learning. Every time we have a mission, we learn something. That gets passed on. We're sharing things across the commercial world. You saw, last year, I'll say, Blue Origin had that parachute anomaly, and the teams all got together and shared across the different companies, what they learned. And to me, that's what this program is helping out. It's sharing the expertise of flying in space. And I'll let Steve and Dana add.
Yeah, I think that's an interesting retrospective way to look at things, Eric. The fact that here we are 10 years into the program, and how are we doing? I would say we've done a great job at fielding 2 transportation systems in fairly record time. If you look at our development programs these days within NASA, Commercial Crew has done an amazing feat of getting to 2 crewed vehicles in 10 years, and really in the last 4 years bringing along online Dragon, Crew Dragon, and then also now Starliner. The unique thing that we're doing as well is sort of fostering this market in low Earth orbit. We already see SpaceX flying non-NASA flights. They have one that they're trying to get off the ground. Polaris Dawn, they flew Inspiration 4. They've flown a number of PAM missions. They've got another PAM mission coming up in the middle of next year. So you're starting to see that market get fostered in non-NASA missions, which was what we want. And then if you really think about our vehicles and what we really want to do, space station's a great vehicle. It's an awesome place. But at some point, the space station is going to need to be retired. And so we're preparing vehicles right now to be there in the future for these commercial LEO destinations as well. So I think it's been an interesting, as you said, and when we started, it was kind of an experiment on the heels of cargo, but now we're starting to see, the benefits of the investments by both NASA and our partners. And that's the one thing that's different about our program, is there's investment from both the NASA side and also, in my case, SpaceX and Boeing, to make the vehicles safe and successful.
All right. Mark?
Oh, thank you. Mark Carreau with Aviation Week in Space Technology. How long would you sort of estimate that it will take the commercial crew program, space station partnering or whatever, to sort of assess this flight and what steps need to follow, just kind of to make a full report that you're all satisfied with, that lay out steps ahead?
Yeah, I think the timeline is a little bit, we're going to take our time to figure out what we need to do to go fly Starliner 1 right. We've laid out right now, manifest-wise, we have that flight booked next year in the second slot of the year. The first thing we'll do when we get the vehicle back is continue to look at all the data, look at the thruster performance for this phase of flight in detail. And then we already have these teams that I've talked about established. They're going to start meeting weekly on looking at the design changes required in the helium system to eliminate the leaks. And then, can we fly the vehicle different? Can we change the thermal in the doghouses? What testing do we need at White Sands? It'll take a little time to lay that out and then get into the testing. And then, I think we'll see where we're at in another month or so, and then we'll have a little bit better idea of what the overall schedule will be.
Okay. Gina, go ahead.
Gina Sinceri, ABC News. I'm not sure who wants this, but we heard a lot about the problems, but what about Starliner's performance particularly impressed you or surprised you in a positive fashion?
Yeah, I would say not a surprise, but if I just look at the 3 flights we've flown, OFT-1, OFT-2, and CFT, you know, the Starliner performance and executing the entry phase has been just about flawless, other than the problem we see with the SIGI when it comes out of the plasma a little bit. It has a little trouble acquiring in one of the receivers, it seems. But if I look at the way the vehicle flies, the thruster performance, hitting the target at the landing site, the parachute deploys, separating the forward heat shield, and getting the drogue parachutes out, stabilizing the vehicle, then putting the main parachutes out, and then separating the heat shield, which is a complicated separation, and deploying the airbags. The 3rd time now we've landed a capsule in the U.S. on land. The entry in particular has been darn near flawless. So that, I wouldn't say it surprised me, but as I step back and think about the mission, the entry itself was just, and the orbit burn was spot on.
Okay, why don't we go to the phone bridge next? We will start with Marcia Dunn with the Associated Press.
Yes, hi. Probably for you, Steve. It sounds like you won't require another test flight, that an operational Starliner 1 with the crew will be next. Is that how it looks as of today? Am I understanding that correctly, that the next flight will be fully certified, ready to go with the crew to be a real crew swap? Thanks.
Yeah, I would say it's probably too early to think about exactly what the next flight looks like. I think we want to take the steps to go look at all the data. Certainly our goal is to get to the rotation flight. Our goal all along has been to have, you know, 1 flight a year, 1 flight from Boeing Starliner and another flight from SpaceX with Dragon. So it'll take a little time to determine the path forward. But today we saw the vehicle perform really well. We've got some things we know we've got to go work on, and we'll go do that and fix those things and then go fly when we're ready. So.
Thank you, Marcia. How about Bill Harwood with CBS News?
Yeah, thanks. And actually, Marcia just asked my question, so let me ask you a different one for Steve Stitch. If a crew had been on board the spacecraft tonight, would anything have been different, or would it just have been the same reentry we saw, basically? I mean, I know you had a quick fly out to get away from the station without the crew on board, but just from a crew standpoint, if they had been on board, just for the record, everything would have been fine. Is that correct?
Yeah, if we'd have had a crew on board the spacecraft, we would have flown the same back away sequence from the space station and the same deorbit burn and executed the same entry. And so it would have been a safe, successful landing with the crew on board had we have had Butch and Sonny on board.
I know that you don't have second thoughts about these things, but would you have any second thoughts about the decision not to bring them back if you had it to do over again, knowing what you know now about the landing?
Yeah, I think it's always hard to have that retrospective look. You know, we made the decision to have an uncrewed flight based on what we knew at the time and based on our knowledge of the thrusters and based on the modeling that we had. And we, you know, if we'd have had a model that would have predicted what we saw tonight perfectly, yeah, it looks like an easy decision to go say we could have had a crewed flight, but we didn't have that. We didn't have a way to take that white sands testing and anchor it in a model. And so I think we made the right decision to not have Butch and Sonny on board. It's awfully hard for the team. It's hard for me when we sit here and have a successful landing to be in that position. But you know, it was a test flight, and we didn't have confidence with the certainty of the thruster performance, and that's really what led us to choose to have the uncrewed test flight.
Thanks.
Okay, next we'll go to Sawyer Rosenstein with NASASpaceflight.com.
Thank you for taking my question. First off, congratulations on that successful landing there. You earlier mentioned about that nav system dropout as it was coming out through the plasma there. Can you kind of explain what role that has, and did that come back online at its own? Was there some ground intervention needed? Just what exactly was done to resolve it?
Yeah, the way the nav system works is we have 3 devices that essentially are like a GPS and then also measure velocity and the orientation of the spacecraft. And so when we came out of the plasma, one of the third SIGI, Space Integrated GPS INS, had trouble acquiring. And so the software said it wasn't performing well. It didn't have enough satellites, and it failed it out. The ground team looked at the 2 remaining systems, SIGI number 1 and SIGI number 2. SIGI number 2 wasn't receiving marks as well as it should have. They analyzed SIGI number 3, did a great job looking at that, and then brought that back into the nav set. And so we had 3 essentially GPSs, and then protected for if number 2 would have been completely bad. So the team did a great job. I think we just need to look at, do we need to allow a little bit more time for the GPS to acquire on the backside of the blackout. And the flight control team, again, did a great job recovering that GPS.
Thank you. Let's go now to Will Robinson-Smith with Spaceflight Now.
Yes, hi. Thanks for taking the time to speak with us after a good landing. Follow up on Mark Harrow's question about timeline, but in a slightly different way. When do you expect that Calypso will arrive back at the Kennedy Space Center, and what's the immediate work that will need to be done once it arrives here? Thanks.
Yeah, don't have the exact timeline. It usually takes a couple of weeks to get it back. One of the first things that happens when it comes back is a lot of the data that we get on board the spacecraft goes through the tracking data relay satellite to the ground, and we can see that telemetry in real time. But there's also recorded data on board. For the test flight, we have a number of sensors across the systems that record data. We'll want to downlink all that high-rate data and take a look at that data. And then really it's a series of analyzing all the data from the entry, the undocking, and the deorbit across all the systems on the vehicle to just see if there's anything that was off nominal. We'll study the data at a little higher rate. So, it'll take a couple weeks to get it back and a week or so to get the data off the spacecraft.
Okay. Thank you. Robert Perlman with Collect Space.
Thank you. When Apollo 13 safely landed, NASA described the mission as a successful failure. Is that how you would label the outcome of this flight, given that Starliner's landing was safe and successful, but it failed to bring the crew home?
Joel, I would not call it a successful failure. We knew going in this was going to be a test mission. We learned a lot. The teams worked together, both the Boeing and the NASA team, to understand the systems of the spacecraft and how they operated. The team worked together at White Sands to understand the analysis that was done. On the test mission, things don't always go as you planned. And so we were prepared. The fact that this vehicle is home, we're very happy to have the vehicle home. To me, a success. Clearly we got some work to do. The teams will understand that work and move forward.
And if you just look at mission objectives, we think we've probably got 85 to 90% of the mission objectives. We docked with the space station. We stayed docked for 3 months, as Joel said. There's a lot of learning that happens in that 3 months that is invaluable for an increment mission. We did a half of an increment, essentially, having the vehicle there, understanding how to work. The Starliner team worked with the ISS team, analyzing the data for those 3 months. So in some ways, the mission overachieved some objectives in terms of being there for extra time. Not having the crew on board, obviously, there's some things that we lack in terms of Butch and Sunny's test pilot expertise at how the vehicle performed, what they saw in the cockpit. We won't have that data, but we still have the wealth of data from the spacecraft itself, and so that will go toward the mission objectives and the certification of the vehicle.
Thank you. Stephen Clark from Ars Technica.
Hi, good morning. Thanks for taking my question. A couple ones, if I could. Steve Stitch, you mentioned a couple of the thrusters on the starboard and top doghouse got a little warm during the deorbit burn sequence, I believe. You said you inhibited some of the limits to prevent them from failing off during that deorbit burn. If those normal limits had been in place, would those thrusters have been deselected at the temperatures they reached? And also, since no one from Boeing is there, Steve, I'll ask you this. What's the kind of the state of the service module for Starliner 1? Is it fully assembled? Do you have to start taking it apart to get to these seals that you may need to replace and any other hardware changes you might need to make before that mission? Thanks.
Yeah, let's see. Relative to the temperatures getting a little high, I don't have the data with me to see whether it would have failed off or not had the software been enabled. We intentionally had planned to fly the flight with the software inhibited even before the thruster problems. We had seen some overheating of some other parts of the thrusters in previous flights, and so we wanted to go ahead and have that flight detection or fault detection system inhibited for the deorbit burn. So I'm not quite sure can answer the question whether they would have failed off. And then relative to the service module for Starliner 1, it's in the middle of being built. We'll get to a point where we have assembled the doghouses at some level, and then we'll have to stop and wait to see what the design changes are. Do we remove some of the thermal blankets inside those doghouses? Do we make some changes to make it a little cooler when we fire the OMAX and also the RCS thrusters? So it is in a state of build and undergoing the final build process, but we'll hold for the final doghouse assembly until we understand the design changes.
Thank you. Apologies if I mispronounced this, but Isam Ahmed from AFP.
Yes, hi, thanks. Yeah, just to follow up on a couple of questions from before. Is there an actual chance that the next flight could indeed be crewed without requiring another uncrewed test? And is Boeing pushing for that, or have they spoken to you about that at all? And just wondering why they're not on the call. Thank you.
Let's see. We'll start from the end there. We did talk to Boeing before this. They deferred to NASA to represent the mission. I will tell you that Boeing has critical work that they do for NASA in the International Space Station program, the Commercial Crew program, and the Space Launch Systems program. And their work is critical to our success, and we fully expect Boeing to continue all three of those programs.
And I think, relative to getting to our final capability of having a certified vehicle and having a capability to do the rotation missions with Space Station, I think both Boeing and NASA share that goal. We would both like to get there. I think we just need a little time to lay out the plan and look at what testing is required and look at how can we validate that testing in flight, and then what would be the risk with proceeding once we understand the design changes. So we just need a little time to work through that.
Okay. Let's go next to Jackie Goddard with Times of London.
Hello, thank you. Yeah, just following up on that last question, we're not getting a straight answer to why aren't Boeing here. I know you all want to be diplomatic, but can you kind of give us an open, honest assessment of, is there a kind of healing process that now lies ahead? This kind of should be a sort of moment of celebration, but we don't have the Boeing folks here at the table. There's no explanation why. It doesn't appear that there's joyful unity, if there is. How do you folks fix the rift? Is there a rift? Is there damage being done to the relationship? Thank you.
Okay, so I'll answer again. We talked to Boeing. They said, hey, we'd like NASA to take the press brief. They deferred to us to talk the mission. I can tell you that the three of us have all talked to the Boeing managers after the landing. The Boeing managers came into the control room and congratulated the team, talked to the NASA team. And so Boeing is committed to continue their work with us.
And I think, from a human perspective, all of us feel happy about the successful landing, but then there's a piece of us, all of us, that we wish it would have been the way we had planned it. We had planned to have the mission land with Butch and Sonny on board. I think there's depending on who you are on the team, different emotions associated with that. And, I think it's going to take a little time to work through that. For me, a little bit, and then for everybody else on the Boeing and NASA team. So.
Okay, next up we have Micah Maidenberg from Wall Street Journal.
Hi, everyone. I think this would be for Steve. Steve, closing the mission, I think, unlocks a milestone payment for Boeing. Is that right? And how much would that payment be? And would Boeing get all of any payment, because Starliner came back uncrewed and I think, as you mentioned a couple of minutes ago, got to 85 or 90% of the objectives for the flight? Thanks.
Yeah, so there are a couple milestones out there relative to ops readiness that we'll have to assess, and then certification is the big one. That's the big one that's coming up. And we're working toward that. We'll have to look at relative to the systems that need to be changed. What does that mean for certification? There were some changes to the vehicle that we talked about pre-flight, that there's some changes to the suits that are going to happen, changes to the seats that affect certification. And then obviously another aspect that has to happen for certification is we need the vehicle to go to both Node 2 forward and Zenith port. And those are all wrapped up in certification. So we're in the process right now of laying all that work out in terms of what we had planned to do, and then obviously what the changes are, and then we'll assess that milestone when it's the right time.
Okay, next we'll hear from Marcia Smith with Space Policy Online. Marcia, if you're online, you can ask your question now.
Sorry, I thought that Michael was still asking a question. But anyway, my question had to do with the crew module thruster. And I'm curious, when was the last time that thruster was tested? And were there any problems with the crew module thrusters on the previous two flights?
Let's see, that's a good question. That thruster, the upfiring thruster, CTU-2, was last used in 2019 on the OFT-1 mission. It performed well. All the thrusters on OFT-1 on the crew module performed well. We did have one thruster that was deselected by the software on OFT-2. This was the crew module thruster. It was very late around the time frame of drogue deploy, and we figured that out to be a command problem. So where the command didn't come out of what's called the integration propulsion controller correctly to the thruster. We took that thruster off the vehicle, and we sent it back to the vendor. The vendor tested it, hot fired it. That thruster worked fine. This thruster today looked different, I would say. In terms of multiple attempts to hot fire it, it had no response at all. The thruster that had failed off due to a command problem had multiple thruster firings. It passed the hot fire in OFT-1, in OFT-2, and then also had multiple firings during the entry. This one, for some reason, just never fired, and so it looked like the valve perhaps was not opening for some reason. So we'll have to take that thruster off the vehicle when we get it back to the C3PF, send it back to the vendor for some analysis, and then we'll know more about what the fixes are for that as well.
Okay, now we are going to go to David Curley with Full Throttle.
You've talked to Steve in the past about, what do we do about the vehicle? Is it changing some of the materials in the thrusters? Is it redesigning the doghouse? I know you have a lot to learn still, and so does Boeing, but how much work do you think is actually ahead? Is it just using a computer to tell the thrusters to fire in a certain way as you did on reentry today to change their performance? What do you actually think you'll have to do?
Yeah, that's a good question, and we have again several teams off looking at that. What we would like to do is try not to change the thruster. I think that is the best path. The thrusters have shown resilience and have shown that they perform well as long as we keep their temperatures down and don't fire them in a manner that causes the temperatures to go up that then causes either the vaporization of the oxidizer, which causes low thrust, or the poppet swells. Today, obviously, the thrusters had all recovered at station, and obviously it looked like today we didn't have those high temperatures. We knew that the downhill phase would be a little less demanding on the thruster than the uphill phase. What we need to do now is go take a thruster at White Sands and make sure we understand the exact pulse sequences that caused the heating, and then at the same time, in parallel, look at software changes to reduce the number of demands on the thrusters. And then in parallel with that, look at the dog houses and see if we can, again, they're trapping a bunch of heat. We know that when we fire the thrusters, the dog houses are trapping heat. Can we go make some changes to the blankets and the inside of the dog houses to keep the thrusters cooler? So it's really 3 different thrusts, I would say.
Okay, next up we have Jonathan Woods with Working Tins.
Hey, thanks for your time this morning. Reflecting back on the question that was asked about the successful failure with Apollo 13, if we think back about 2020 when Crew Dragon Demo 2 launched, I think the most significant issue that we faced during that mission was launch scrub due to thunderstorms during it was Tropical Storm Bertha. Thinking about that, when we say this mission is a success, how do we position this versus the relative success of a 60-odd day mission with Demo 2 compared to the insurmountable challenges, the testing, and everything that had to transpire to make the difficult decision to keep crew on board station for a very long duration mission?
Yeah, I'll take it and see if Joel has anything to add. When I look back at Demo 2, Demo 2 was very clean in flight. However, I think a lot of people forget that after landing, we discovered there's a device called a tension tie that goes in between the Dragon spacecraft and the trunk that attaches the two together. And there's a very complicated thermal protection system closeout around those tension ties. We found out after the flight that we had some erosion around that thermal protection system area, and we had to go change the design in between Demo 2 and Crew 1. We made some substantial changes to that closeout and then went and flew. So Demo 2 had its challenges as well. I think every test flight has its challenges. What we see with Starliner is a very robust spacecraft, but yet we have some challenges with the thrusters that we've got to go attack and move forward and fix. I wouldn't call them insurmountable. I think what we've seen out of the Boeing and NASA team is a resilience and able to overcome challenges, and we just need a little time to go work through it. I think we learned a ton during this flight, which is invaluable moving forward to Starliner 1. Now we just need to take that learning and make some changes to the system so that we don't overheat the thrusters, and I'll see if Joel has anything to add.
Yeah, the only thing I'll add is, the lessons learned that we have on these demo missions play forward to other future missions. The question was asked earlier, do you think the programs, the commercial programs have been a success? And yes, these lessons learned that we're able to take from both the Boeing mission and from the Dragon missions are lessons that we are carrying forward for future missions and future providers such that we can continue to develop the low Earth orbit commercial.
I would just add that it's really hard to compare the Demo 2 mission to this mission. Keep in mind that we took a different path with the Dragon vehicles. We developed cargo capability first. So by and large, things like dealing with prop systems and a lot of the things that we're now learning with the screwed flight test were dealt with during the cargo era. And then we upgraded the vehicle for crew. So very different development paths between the two spacecraft.
That's a really good point.
Thank you. Okay, next we're going to hear from Mike Wall with, I'm sorry, it disappeared, but Mike Wall.
Yeah, hi. I'm with Space.com, actually. Thank you for taking my question. Yeah, I just wanted to say, first of all, congratulations on a successful landing. And second, I was just wondering if you heard anything more from Butch and Sonny, just kind of how they're feeling today, what their reactions were to the landing, and just how they're feeling about, like the next few months that they'll be spending on orbit. Thanks.
I haven't spoken to them today. Obviously, today was really busy. They were on board doing a lot of work for us. They did wish the vehicle well and best wishes for the landing. And of course, they watched it the whole evening. So no updates from what I reported before. After station's always busy. I know I always tell you guys that, but after Starliner departed, they were off working on other activities for us. So right away, they jumped into some other work. So no other updates from what I've reported to you previously.
Okay, and we've got one more question on the phone bridge from Sophie Sanchez with Cosmic Chicago.
Hi, thank you for taking my call. I had a question about the failed thrusters that were mentioned. Was the redundant thruster that you mentioned part of the same system? And just a hypothetical question, I guess, if that had failed, what would have been next, and what could have happened if they both failed? Thank you.
Yeah, we did have a redundant thruster available on the crew module to do the function that we needed. We did need that thruster to work during all of entry, so I wouldn't say all of entry, but through the highest part of entry to a certain phase. If that thruster would have failed, it would have been acceptable. But once we got off the separated from the service module, we no longer have those thrusters. So the one remaining upfiring thruster worked just fine. We'll go back and understand what happened with the CTU-2 thruster that failed, and we'll go solve that problem and move forward.
Okay, we did have one more question come in from Kenneth Chang with the New York Times.
Yeah, hi, thank you. This is for Steve Stitch. So during this news conference, you've outlined a bunch of work that you need to do, especially with the thrusters and the doghouses. In the past, you've also mentioned that it's really hard to test the doghouses on the ground because getting the whole system to mimic what you see in space. How will you be able to get enough data through simulations and through testing that you have the confidence for Starliner 1 without flying another test flight?
Yeah, that's a great question. We're going to take the data from this flight and work to build models on the ground, and then we're also going to look at, is there a way to test what I would call an integrated doghouse on the ground in a vacuum chamber. We've got some ideas on maybe how to do that. At White Sands, we'll put a team together to see if we can actually put it in a chamber and fire the OMAX and the other thrusters and get that data in that environment, and then extrapolate that data to the orbit vehicle. So there may be a way. We just need a little bit of time to work through that.
All right. Well, I think that is our last question, so we will wrap up there. Thank you so much to our briefers for sticking with us through a late night. We really appreciate it. And thanks to all of you for following along with Starliner's test flight. We appreciate that as well. Please continue to stay tuned. Next week, Wednesday morning at 10:15 a.m. Central, 11:15 a.m. Eastern Time, we're going to be having the coverage of the Soyuz MS-26 launch, carrying NASA astronaut Don Pettit and his cosmonaut crewmates Alexei Ovchinin and Ivan Wagner to the International Space Station. So more to come in space. Please stick with us, and we appreciate your coverage. Thanks so much.